on. Okay, well, welcome. Thanks everyone for coming. I've assembled a panel of luminaries. You probably know everyone here, but I've got some slides here to introduce everyone. So I'm Shaun Smith. You don't know me, but I am wearing the same t-shirt as I have one shirt apparently. I work on the GraalVM team. I'm joined by, on the far end, Thomas Wuerthinger, who's the founder of the GraalVM project. I've got Max Andersen from Quarkus, Red Hat. Sebastian Deleuze, who's what's your position title, Sebastian?
Spring Framework Core Committer at VMware.
Okay. And Graham.
Better in French.
And I'm sorry, I made up the microphone here. And what am I doing here?
Yeah.
What a terrible.
I had one job.
I had one job. Can you see if that's on? I don't not put it near this mic.
Yeah. Graham ROCHER.
Thank you.
Architect Micronaut.
Right. So everyone's from different leads of the different projects, and if you're a Java user, you're probably using one of these frameworks. We're building microservices, and so what we're here to talk about is how those projects are taking advantage or using GraalVM Native Image. So we won't go into like what is GraalVM Native Image, what is Spring. I think you probably have an idea what that is. We'll look at some of the benefits, the challenges that everyone's facing, and we'll start off with sort of an interesting question I thought, which is not working. Now, all these frameworks aren't the same. So the question is, and I haven't told them the questions in advance, right? So what's the philosophy? I think everyone's got different, even GraalVM has a philosophy of the sort of underlying what you're trying to do with the frameworks. And they're not all the same. I thought that was interesting to ask you, as users especially, like what are these frameworks trying to do, or these platforms trying to do for the user? You want to start? You're right beside me.
Yeah, so I think with Micronaut, our goal is intelligent compilation, so moving more into the compilation phase, having a smaller runtime footprint. So the more we can do at compile time, the more we can optimize ahead of time before it gets into the AOT phase. And that's, our goal is basically efficiency, but trying to balance that away with high developer productivity and
right. Throughput. And I sort of asked the question, is it, sorry, the head of Meta, what's his name? You know, that guy. He had this whole move fast, break things. And I thought of that because I know that doesn't apply, but I don't think you would say that that's not Micronaut's. Micronaut's a bit on the move fast, break a few things, not too bad, right?
Move fast, but we follow semantic versioning. We can't break things fast. So.
Yeah.
Okay, almost everybody knows Spring, so we are the leading framework in the JVM ecosystem. Spring Boot is the default entry point for most of the application. And I think what we try to do is to provide a pretty stable API, so we try to be super careful in terms of not breaking your apps, because millions of applications are based on Spring. And at the same time, we try to support the latest technology, including GraalVM Native Images, and doing those two things is super challenging, because we need to support the latest and greatest technology to improve runtime efficiency, and at the same time, not break all the existing huge code base and user base. So, yeah, this is a challenge we try to
and you're bringing a lot of people forward, so there's a lot of older apps they're trying to bring forward to 3, say?
Yeah.
And let them take advantage of this, right? So you have a large installed base.
And we try to move forward a bit the ecosystem by, for example, in Spring Boot 3, we made the choice to use Java 17 baseline in order to, so that's a bit of a bold move, but that also push the ecosystem, the Java ecosystem to move forward. So yeah, finding the right balance between not breaking your application and supporting the latest technologies, it's the challenge we try to solve.
Cool. So Quarkus is the leading framework in native image.
Okay, so I should say this is not a cage match. There'll be no. I'll constrain Max a little bit.
I had to do it.
Go ahead. We want some spice, Max. We want some spice. Go.
Sorry. No. So philosophy of Quarkus is we want to make Java relevant and have it stay relevant, and we do that by ensure we have performance and developer joy. And you talk about philosophy. Our stuff since day one has been to move everything, well, not everything, as much as possible to build time, which you've heard multiple people talk here at the conference. That we started doing that in 2018-19, and we've been very successful doing it. And we do it not by trying to move everyone along, but move all the major frameworks like Hibernate and Apache Camel and REST East Reactive, and make them, have very efficient throughput, and even without native image, it's good. And then because we do that, we can give the developer joy, which is a key tenet for us. And then because of the way native image works, we can utilize that better and get even faster startup time. So it's all kind of combined, and move Java forward.
So what's our philosophy, Thomas?
Yeah, so the philosophy of GraalVM is to provide the most energy efficient and most cost efficient execution for Java programs. And efficiency here means startup, where we, of course, everybody knows our startup numbers are super good, but it also means lower memory consumption and lower total CPU consumption while you run and warm up your application. And as a side effect, also more secure application execution.
That's very good. Okay, so Max, so basically you're trying to bring a lot of frameworks, like you guys provide a lot of frameworks or versions of frameworks that are designed to work with Quarkus, right? So you're trying to do that.
Yes. So one thing that is different is that we've focused on actually taking frameworks and use some of the tricks you can do with native image to make them native out of the box.
Right.
Others wait for those frameworks to come around and come up with a version that has it. We try to kind of jump ahead and provide it in a lot of extensions. We have about 400 something extensions now, making native image available for a large part of the ecosystem.
Yeah.
On that, I think there is some differences. On our side, we try to collaborate with the GraalVM team, the Micronaut team, to on a reachability metadata repository that basically is a shared effort across the ecosystem to add the required metadata to run various libraries. And so that's a challenge because we need to agree across different frameworks about the right approach. But since this compatibility and metadata is a remaining pain point, and I think you did great progress with the latest Oracle GraalVM on performances, for example, but compatibility and long build time are the two main current drawbacks. At least share this pain, and also in terms of framework side, in order to make the user side more easy, and also try to increase the scope of what is supported in terms of libraries, have good testability, and that's pretty successful. I think we have too much PRs, so there is a bit of a struggle to process all the metadata that are contributed by the communities, but that's a good problem to have, and happy to work on that with other actors.
Yeah, on that subject, the compatibility with what we were trying to really prevent going forward is what I like to call islands of compatibility. So native image needs to be universally supported across all the ecosystem. So it's great that we work together with the Spring team, the GraalVM team, to create the shared metadata repository where we have a combined set of tests for the whole community where we can test and build and assert that third-party libraries work instead of there being, you have to use Quarkus or you have to use Micronaut or you have to use Spring. Essentially these islands. We also work really hard to ensure there's great tooling. So we make, on the Micronaut side, we make very heavy investment into Gradle and Maven tooling that we collaborate with to build great Gradle and Maven plugins for native image, so you can efficiently build native images with your favorite tool chains.
Okay, you hold those. Yeah. Okay, so that's a good start. So I think you've touched on this already, but basically, why did you do it? Why did you work with native image? Why did you add native image support to the frameworks? Like, what's the benefit you're trying to convey to your users? Like, I think it's almost the same. It's probably the same answer, but maybe not.
So I'll go first since I had the microphone.
You had the microphone.
I think with Micronaut and GraalVM, we were on like the same journey before I heard about. We will, with trying to achieve more efficiency, more efficient runtime, smaller, lighter weight processes. And initially with Micronaut, Micronaut is different to a lot of frameworks in that it's, we wanted to eliminate uses of things like reflection, dynamically runtime creation of proxies, runtime bytecode generation, anything that can add weight to the runtime, we wanted to eliminate that. And as when GraalVM initially came out, we were like, to be compatible with it, you need to, configure these things that like dynamic write bytecode generation, like reflection. And we didn't do any of it, so it was really, it was right out of the box.
Kismet.
You know, we had like Micronaut working with GraalVM, I think the first framework to do it, and it was working, you know, within a week, and this was like, wow, this is
so like
next level.
the philosophies aligned, basically.
Philosophies aligned, yeah.
Yeah.
So on our side, we have put a very significant R&D and effort in the Spring ahead of time transformations. Basically, a few years ago, I created a Spring Foo project, which had two goals. Basically, allow to configure a Spring Boot application with a nice Kotlin or Java DSL. So this is more the developer experience configuration part. But also, we've seen that leveraging the functional bin registration capabilities we have introduced with Jürgen and the Spring framework team, we were able to basically start faster, have better efficiency. So combining this experience in the Spring Native experimental project that I had the pleasure to lead, we have been working multiple years on making Spring compatible with native, with the level of quality we were expecting. And again, the challenge is that we have millions of applications working right now, and we want to allow those applications to compile to native without changing them. So the challenge is a bit, challenging. And so, this Spring IoT optimization is, moving the reflection and the discovery of the structure of your application from runtime to build time, with some additional constraints, of course, because everything is about trade-off. And I think we have a focus on keeping things maintainable, because, for example, we have raised the baseline to Java 17. We have a lot of other topics to cover because wide usage. So, I mean, for example, we try to have zero substitution, which are some kind of patch where you don't really know the code you are running because you are overriding the code from your open source application to take a shortcut, and we try to avoid that. So maybe, that has also some trade-off, but we try to, move forward and provide the best runtime efficiency, but we will never basically sacrifice the maintainability and some principles. So we try to do that with the Spring IoT engine, and we will continue to refine it to provide Spring native support for Spring applications, existing and new ones.
So the question is, why did you do it?
Why did you do it? Well,
integrate.
Why? Well, the great thing with Native Image on Graal is it's available today, or available a few years ago, so we could do something today. And what Rydahl has been doing is working with GraalVM. They have GraalVM runs on their own OpenJDK, Oracle Labs JDK. In Red Hat, we would like to use the OpenJDK, let's say, straight up version. So we've been doing the Mandrill product, which is on the Graal, which is Native Image running on plain OpenJDK. We're doing that, and then we've been adding stuff to being able to work with GraalVM and Oracle about adding stuff like JFR, monitoring, debuggability to Native Image, so we can have those benefits as we have in Java. And yes, we are very happy to use substitutions to make frameworks today able to move forward and have it today instead of X months or years out. And we built Quarkus to make this maintainable. That's if you look at what Quarkus at core is to make a build time, make this build time stuff manageable and maintainable. And anything we find and move, we might be having support for Hibernate before Hibernate proper has it, but we contribute back to Hibernate. We've done similar thing with Netty, and recently we worked with Jackson. This was less about Native Image, but giving support for virtual threads in Jackson, because they had even though that Brian Gert said virtual threads support thread locals are very, very expensive in Loom. So we worked in that way. And there's tons of examples of we don't, we have the stuff in Quarkus, but we go back to all these communities and contribute. So their next version has it out, and then we can remove the substitution in Quarkus. So, but we want to provide it now and today instead of n number of years out.
Okay, maybe Thomas can comment on what the value, like you've got these integrations from all these different frameworks, and what's it bringing.
Yeah, and I'd like to talk a little bit about, like, when we first came out as GraalVM, Native Image was only a small part of the whole stack. And, we came out, and a couple of months later, GRAEME and the Micronaut team were starting to publish benchmarks using Java servers on Native Image, which we never anticipated to happen. And they could start the Java server in 5 milliseconds, and it was very exciting. And that's where we started to realize, oh, this is actually could be a big thing for Java server-side applications. And then basically 6 months later, or like a little more, suddenly out of the blue, without telling us before at all, Quarkus was released from Red Hat. And we looked at their main website, and they're like, oh, native image is great, and it has like this super good startup, and it's integrated in Quarkus. And they kind of took it even further in what you could do with our stack, what we even couldn't imagine back then. And then we were also super grateful to see then the Spring team to start a really big effort to bring the whole Spring user base towards native images, such that today we are in a position where if you start a new application in one of these frameworks, it will like work almost out of the box in most cases, as long as you don't have a strange third-party dependency that you've added. And so this framework support has been super important for us, and it's super exciting for us to see how the frameworks have helped together with the GraalVM team to build this super efficient Java for server applications.
Thanks, and yeah, to answer more specifically to your question, because I was borderline off topic. Why we do that? It's basically we want to allow Spring application developers to be able to scale to zero their workload. So basically be able to shut down, basically a generalization of serverless, but you don't necessarily have to implement a function programming model. You can basically do that with any kind of traditional web application in order to get, when your application is not used, basically you don't pay anything. So it's more about also the billing model than just the technology. And also just to be careful about the sustainability and the memory consumption, etc. And leveraging, I think we have 50 times reduction of the 50 times faster startup time. Mm-hmm. So even big Spring application in cheap servers start in dozens of milliseconds on production. Right. Not on my powerful MacBook Pro, on production on cheap servers, 1 or 2 vCPUs. Mm-hmm. So that's a game changer for this kind of metrics and the reduction of memory consumption. I think that's a very good match with the cloud hosting, where Java has been a big challenge. Motivator. And so for Java in the cloud, that means you have some constraints, and in concrete project that you may develop, it's maybe harder than just an Hello World and Pet Clinic to support, because your library may use reflection. I mean, I'm working with some companies, with some project in my company to port them to Spring Boot plus native. That can be a bit challenging sometimes, but the reward is really worth the effort.
Okay, so you keep talking. So the next question is, how easy is it? So is it? I'm thinking it's a piece of cake, right? That's the right answer. But how easy is it? So if I'm a Spring user, I go, I'm going to develop with Spring and with native image. Yeah. Like I know today it's quite simple for the basic, but you're saying it's not always.
I mean, the basic is simple. I mean, sure, you are creating a new Spring Boot plus GraalVM native application on Standard Spring.0. It will work out of the box. Pet Clinic, you have just 1 or 2 things to specify. It's not the issue. The thing is that you are going to have this long compilation cycle. Okay. Have to find what breaks, because you don't have a magic way to understand that. So this is maybe this cycle of maybe fixing your own code that is using reflection, resource loading, etc. The specifics, not the popular open source libraries, not Spring itself. We are inferring almost all the configuration. Just something specific to the JVM ecosystem, the libraries, your company-specific libraries that are designed for Java, that are using reflection.
So Spring itself, you've done a lot of work to make Spring itself working. Yeah. It's all the third-party stuff.
Spring AOT is basically optimizing everything to have good runtime efficiency, and is going to infer all the GraalVM metadata required to run your application for the part on Spring side. The difficulty is more all the libraries that you are using that are specific to your companies, where there is not necessarily metadata. And here there is some challenges. There is some improvement, because recently you have added the capability to just do one native compilation and get all the missing metadata, instead of doing this very long cycle to one thing break, I fix, I do native compilation, etc. So there is some big improvement that you have made, and thanks for that, because I spent most of the 4 past years doing this kind of thing. So
one bug at a time.
But so it's improving. You have fixed the performance issue, mostly with Oracle GraalVM, with the constraints you have with Oracle GraalVM. So I see some drawbacks reducing, but yeah, in terms of developer experience, we mainly ask people to continue to use the JVM as usual and use native as a kind of optimized deployment for their workload with container images.
And that's because of the slow compile time currently.
Yeah, slow compile time and the fact that you need to find this metadata, these hints that are missing to make real projects that people are really using, fully compiling, not the framework part, the libraries,
Right. So maybe Graeme. So is it the same story? Basically, it works if you're using Micronaut. It's third parties.
Yeah, I mean it's not exactly the same story. I think the approach between Micronaut and Spring is very different. Spring, to my understanding, correct me if I'm wrong, but it generates a lot of it infers the metadata and passes it to the native image tooling in order to make the program compatible. With Micronaut, we basically don't pass any configuration to native image, not for Micronaut itself. It's zero extra native image configuration, because the bytecode is already ready to be passed to the tool. But we have the same challenge when it comes to third parties. So when there's a third party, and that's why the shared metadata repository is important, like for the open source ecosystem. I got to also say that since we moved as well to removal of the use of substitutions and some of the custom build time initialization flags, it's easier to reason about and troubleshoot failures in the native image configuration. And I think it's nice to have that consistency between JIT and the advancements there that have happened recently. So
we have the metadata repo fans, and then we have the substitution fan. He's going to say it, right? We ask him. So how easy is it, Max, to use native image with Quarkus?
I just want to say I'm a fan of the metadata repository. It's just, and we can actually use it. This is, and we had a week ago we were in Zurich talking about this.
Yes, we had.
I'm still a fan. Yes. It's just that we kind of have a lot of stuff already that is working, and people can, if there's a framework, if you add a existing application, even a certain Spring application can run on Quarkus almost unchanged with the Spring compatibility layer we have. So we try to do everything to make it as easy as possible. From day one, Quarkus was just one plugin, one Maven or Gradle plugin that you put in, and we take care of all the native image building for you. No extra setup. Anything that has to be generated, we just kind of do. And in that sense, we still feel that to add something to a Quarkus application is add an extension or add the library, and in many cases you don't have to do anything for native image. And so we've spent so much time on making sure that just kind of works. So it's at the level we call it boring. That it's no longer a thing. Right. And I was talking to Alina. Yes, sorry. Yesterday we were doing the workshop for Quarkus. And I was like, I'm sorry, we're not going to spend too much time on native image because it's just a flag in Quarkus.
So this is success because I always say there's no glory in infrastructure, right? If you're down there doing your job, no one knows you're there.
That's what it is. Yeah.
Okay. Joyful developer experience.
Just to add something, so on Spring Boot we are just leveraging the fact that you are adding the native build tools that we built together with the GraalVM team as a signal that you want to build your native image. So you add this Rydahl and Maven plugin, and then the native support is enabled, and everything is supported in the various Spring portfolio projects.
And I was confused actually when I first got the Spring 3. I'm like, where is it? It's in the parent POM, so it's baked in.
Yeah.
And same with Micronaut, it's just baked in.
Exactly. And to just add a bit more precision, so the Spring IoT engine is going to do two things mainly. Is going to transform the annotation-based programming model that we are all using. I mean, we are all using the same kind of programming model. And basically, at build time, it's going to transform it to Lambda pre-computed conditions that is basically automatically analyzed by the GraalVM Native Image compiler. And as a side effect, it starts also faster on the JVM, so that's a good thing. And it's going to infer the remaining part of the reflection that we have not removed, and also the part of the hints, the metadata that the user need to specify for their own libraries, your company libraries that may still use reflection, that need to load some resources or use proxies. So there is a fact where we provide a kind of, a nice API to specify ints with Fluent API.
So the summary is really you should use a framework with Native Image because everyone's working to make it easy, right? This is
native without a framework.
It's a bit more painful.
Not going to fly.
And I think we're taking like different approaches. Like when I mean, like for example, one of the things we've done on the Micronaut side is we built a serialization implementation. Now, probably a lot of people think this is crazy, but we basically have a almost Jackson compliant serialization library called Micronaut serialization, and it's key for Micronaut because we can serialize and deserialize JSON, which is obviously one use case, but it's also integrated into every layer. For example, Micronaut data, MongoDB, or Micronaut data with a document database on Oracle or wherever is using Micronaut serialization under the covers.
And Jackson is a major pain.
And Jackson is because that's something you know.
It's everywhere.
And you know, finding we even integrated Micronaut serialization into, for example, certain cloud SDKs, so that when you send a request to the cloud SDK, it's using Micronaut serialization instead of Jackson. So we've done a lot of work to make that particular use case, hassle-free.
Right. Okay, let's pass it to Thomas. And I don't know if you saw this tweet from Dan Vega. He had like, these are the great things. I thought, what's your favorite thing? Thomas, what's your favorite thing? I think maybe you mentioned it earlier. And of the things you can do, instant startup, no warm-up, low resource consumption, reduce security, improve security, right? Easy to package, and lower compute. You started off by talking about sort of less energy.
Yes, I like to emphasize like one of the things here, which I think is Native Image is less known for, which is the improved security posture. Because like people, of course, say, oh, this reflection configuration, it's such a pain because I need to say what's reflectively accessed and so on. And that's, of course, true. And thankfully, the frameworks reduce a lot of this pain. But the big benefits of taking that pain is that you are reducing the attack surface of your application a lot. And if you look at the history of the last 10, 20 years of Java server-side vulnerabilities, then a lot of them are related to an unexpected reflective access or an unexpected call or deserialization of something that shouldn't be deserialized. So I think this is a benefit of Native Image that's underappreciated, and sort of it helps a little bit take the pain of having to configure the reflection that this actually makes the application more secure.
What's your favorite feature?
My favorite
And it
feature?
doesn't have to be on the list.
No.
What's the biggest thing that you think contributes, right, to your users?
The biggest thing is it's here today. Right, that's for sure.
It's
here
practical.
today.
You can buy it or you can download it.
Yeah, it's just here today. Right? No, it's like
Not vaporware, that's what I'm hearing.
It's not vaporware. It runs fast. It gives high throughput. That kind of thing. And I just I want to say the big difference, or the big reason why we've worked with GraalVM for a Native Image for this many years is these kind of conversations we have. Like we have every year so far. We had this meetup where we meet up and say fun things about each other, and talk about the stuff that we can do, and the fact that we've been able to collaborate and add stuff to this that can be used in production today. And again, I'm repeating myself, but I think that's the biggest main feature of Native Image. It's here today, and we continue to work together, and you are okay to add the stuff like substitutions and other things that allows us to help everyone move forward, and that's a big win compared to other approaches.
Yeah, and more globally, I think I'm really thankful for the GraalVM project to push the boundaries in terms of runtime efficiency. I think your impact on the whole industry and JVM ecosystem has been totally huge. So there is what you do on GraalVM Native Image, but there is the fact that you are moving the whole industry toward more runtime efficiency for the JVM and in the cloud and Kubernetes, serverless workloads, etc. And I think this is something that is underappreciated. Like I thank the Kotlin team that pushed the boundaries on the Java language side, and we have also, not only for that reason, but I guess it has been a reason for getting new nice feature in the Java language. On the runtime efficiency side, I think you are pushing the boundaries and challenging the status quo. And the impact is huge.
For me personally, I just think that GraalVM provides the best, simply the best set of trade-offs. Because there's different solutions out there to this problem space, right? Where of fast startup, low memory, but the trade-offs that that GraalVM offers are unrivaled. Of course, there is some compromise. There always is somewhere, but if you look at the other solutions, I'm not going to name names. They always the set of compromises is way worse. You either drop like memory consumption is way worse, or security is way worse, or that the compromises are not great in anything that's out there today. And like Max said, it's available now.
And it's also important compared to the other technologies. Sometimes in the JVM ecosystem, in Java conferences, we are focusing on our stuff. And yeah, we are in a world of containers on multiple technologies that, like Go, Node.js, etc., that are sometimes challenging a bit the JVM ecosystem, and be able to keep the nicest feature and benefits of Java, and be able to compete with these other technologies with some Java workloads it's super nice, especially in this container world where we live.
All right, well, I'll give you the flip side question, right? So like, what's missing, right? Like, what is it you're like, why didn't Thomas have the team do that?
Well, I
think you have to be really nice because you work for the same company, so you got to be.
Yeah, I mean, no, I think I'm super excited about the possibilities going forward of potential, layering and that kind of thing. I think that's like probably missing
build time improvements,
and the possibilities for build time improvements. And that's
is everyone going to say build time, like faster builds?
Probably.
Probably.
But I think the last few releases have made like massive jumps in usability in terms of error messages, in terms of output, in terms of just the general developer experience. So there were in the early days there were maybe a few complaints about like, oh, this is a weird error, and it's kind of confusing. But now it's like more consistency and
so before you would get errors and you're like, I have no idea.
Yeah, that right. Feedback, okay. But that's really
better.
That's a lot better.
Yeah, I think if you can keep the nice runtime efficiency characteristic that we have today and reduce some of the drawbacks, and yeah, it's hard because everything is about trade-offs. So usually when you are going to improve something, you are going to lose in the other end, but you have an amazing team of compiler engineers. You are doing wonders. So if you can keep the nice runtime efficiency that we have in containers and be able to reduce a bit some pain like you did for the performances, and leveraging the fact that maybe you have more CPU budget to do crazy optimization on build time or place on some of your competitive advantage, that would be great. What I would avoid is that we lose the runtime efficiency that we have to gain on other parts. But I know this is super, super hard.
So I have three things.
Oh.
But yeah,
this isn't an essay question.
No. But I just think because they were like, Well, the important one is your build time. Time of build, like how long it takes to take builds. That's the big switch. Cross compilations would be a massive win just to compete with other ecosystems like Go or that kind of thing. I know it's a pipe dream, but hey, there's no limits.
I asked the question.
Yeah.
Like, what do you want?
And then I'm not saying missing feature. I'm just like the early days of Quarkus and Micronaut and Spring. We actually had faster startup times because the defaults of GraalVM was more aggressive. So I'm missing that time.
Startup.
Yeah, so what Quarkus is encouraging build time in it. So we do that, and we've had discussions back and forth. And we take the benefit of being the new kid on the block, or one of them. And we are pushing users to default to do static init.
So initialize at build time.
Initialize at build time.
And we are now recommending that
which you did in the
default,
early days.
Yeah, but we changed our mind.
Yeah, because you wanted more of the
Safer.
old stuff to be there.
Safer, right?
Yeah. No, I get why, but you were so kind, which is good, to let us have the flag where we can flip the behavior. So
be bad, basically.
Yeah.
Do that.
Say, hey, please go back to the old one. And that helps us move the rest of the ecosystem forward. Again, and that's the, yeah. So I'm not asking you to flip the switch again, but I'll just keep those switches on. So frameworks that has the ability to do so can utilize that stuff. So
what you're seeing is there's a lot of diversity. Like you think, oh, I'm using Spring, I'm using Micronaut, and there's a lot of differences. under the hood? Like the philosophies are there, build time initialization versus late initialization. It's not all the same, right? So if you're using these frameworks, they're not all the same. It's just not, oh yeah, I have an at get on some sort of endpoint. That's not the end of the story, right?
Yeah, and the big thing you'll see is the difference in developer experience and more like Java in normal JVM behavior. But I think on native image we have the one in common that is still Java, and yeah, it's native image execution that can run in containers and on other stuff. So.
Okay, so I'm wondering, Thomas, what's missing? What's your favorite thing or what's your favorite project you want everyone to work on?
So I actually have one, and so the thing is with native image, we want to, like, one of the things that's currently native image helping this is that when you start a Java application on a JIT mode, the JIT compiler would always recompile everything and would recompile Java long integer dot value of and Spring hashcode, etc. So the JIT compiler would do all this work quite repetitively whenever you start your Java application. And with native image, we got rid of that. But it's still the case if you now develop an application and you build an image multiple times, we will start from 0 and we will compile the image, and then you make a small one-line change in your application and you need to again compile the whole image and so on. And we think that's against the philosophy of the GraalVM project. And we therefore think what we can do is we can allow you to build what we call layered native images. And this means that you build an image once for your dependencies, and then you only build the small things on top that you actually changed. And this could really bring us also from a developer experience perspective to the next level, because it will mean if you do a small change in your application, it's going to rebuild in 1-2 seconds instead of maybe half a minute. And the other benefit of this approach is that you will be able to share, for example, in a Docker base layer or on a server where you run multiple applications, you'll be able to share that base image. And we discussed this last week in the GraalVM community meetup, and we are looking forward to work together with the frameworks such that each framework can then also help users provide a base image. And in this way, a lot of the work that's redundant is then shared and no longer there. And native image is suddenly also attractive, not only for deployment, but also for development.
Because Sebastian was saying, today the recommendation is work on hotspot, it's fast, and then you sort of every so often do a native compile, right? If we make the native compile take a couple of seconds, changes the whole thing.
Yeah, and so this is the most important project we currently think we should do a native image, and therefore the best
engineers are on it.
The best engineers.
Are you working on that, Thomas?
No. The best engineers are other engineers on the team. Some time ago, that I was among this group, but we have many great engineers and on the GraalVM team, and we're collaborating with the frameworks to make this happen as soon as possible, because we think this will be a step function. Of course, we're going to incrementally improve, further our metrics. But this is the thing what we would consider a step function in terms of what native image can do in the Java ecosystem.
So in addition to those developer experience improvements, which are deeply needed, indeed, the AI-based PGO improvements are close to my heart, because
we should explain this. We should explain what that is. I don't think everyone knows what we're up to. Yeah.
So basically, currently, when you are doing a native compilation, you will have a slower throughput. Record GraalVM is faster, but than the JIT because there is no JIT. And so the recommendation currently with the Record GraalVM is to use profile-guided optimization. So basically, you run your application with an agent that will record some data, and then that will allow to know the hotcode path and optimize everything. It's an additional pain, and native image has a lot of big benefits, but a lot of strong pain points. And so I would hope that we are not adding the let's run your application ahead and basically get all those profiling data thing, and instead leveraging, I think, some R&D work you are doing using AI. Like AI is going to be able to guess what kind of optimization makes sense for a Spring application. Like usually the request comes through the controller, which is calling the service layers and the repository. And I'm pretty sure the pattern is not that complex. So I'm pretty sure with your crazy engineer team, you will be able to optimize things like that. And if we can get the advantages of PGO, profile guided optimization, without the pain of running that, with the AOT optimization, it has the potential to be faster than the JIT without any JIT. So that's a bit crazy, but I think that's doable.
Maybe you can talk some more, Thomas, about this, because we already have some support, some machine learning. I don't know if everyone knows that the machine learning optimization is on by default in 21.
So if you use our GraalVM, we already try to basically ask the AI, like what should be the profile for a method. And the way you can think about this is, if you have an if branch into a throw exception, then we think like it's probably not going to be very often executed. And if you have a tight loop, we think it's probably going to be executed often. And we have a little bit of that already, but it is a major goal for us. I mean, now that we have reached a very big milestone in the last release, that with PGO, so if you do a PGO training run, we are beating on peak throughput, the JIT compiler, because we can use the information from the pre-training run and do the best optimization. This is a big milestone the team has achieved in the last release. And the next milestone here will be to do the same, but without the user requiring to define the training run. Because we feel that defining a training run or needing to warm up something or needing to start something and then snapshotting it and so on, it's too much complexity in the development workflow. And this is why we will improve our AI-based generation, but we will also try to work with the frameworks again to have predefined profiles for each framework, such that if you are building a Spring application or Quarkus application or Micronaut application, then if you don't provide the profile for the Micronaut Spring parts, we will have predefined profiles for that. Because profiles need to be only very approximate to already make a very big impact.
The current one we have is for what, Java base or so, and we're getting like 7%, improvement from this machine learning based optimization on top of the other stuff we do. Okay.
So the fourth item is to have that open source.
Okay. Thanks, Max. Okay. So I want to pivot off of something Max said. So the question is, right, who are we fighting here? What's our goal? Is the goal for GraalVM, is it to make it, fight off the Rust forces? Or the goal, or is it really, should we put our energies much more into like, okay, run more Java apps? Right, so is it about running any old Java app, like make it sort of compatible and more boring? Or is it really like keep pushing on the speed, keep pushing on the advantage so that Java developers don't start bleeding off into these other languages because they feel that they can't get what they want for Java?
Very open question, but
open question. So you mentioned that we don't want people go to Rust because they have all this great stuff, right?
So the variation I play, and I want to talk on this story, is that Java over the last 10, 20, is it 25 years now, has done 1,000 paper cuts to itself. Like we have frameworks, Spring, JBoss, WebLogic, App Service. We've all built up this complexity. So I'm personally, I doubt that if we're trying to move that into all those into native, I don't think we'll get there. But I do think that by refreshing what we're doing and being able to utilize stuff like substitution, again, I'm repeating myself, and bringing those frameworks out there and pushing the line forward, so that when there's a discussion somewhere about, hey, we're gonna do this new thing, the existing apps we have is taking up 400 megs or X, Y, Z, that Java is on that option to go, right? Because I don't like existing apps they will stay around for a long time. It's the new choice, right? And that's
so you're looking forward. You're more concerned about.
It's always a mix, but it's when the new app comes out, because you've seen that historically. Anything that is okay and work, you don't touch it. It's in production. It's fine. But anything new, you want to make sure that Java at least is recognized as, hey, we have an extremely high-performant JVM mode. But you also have these options that are, being popularized the last couple of years. Hey, you can use Rust or Go or something else. But Java definitely, needs to be in the top of mind of those people.
Competitive.
Yeah, competitive.
Yeah.
And you're a WASM fan, so.
Yeah, I was. Oh, you're reading my mind. Okay. So yeah, I think what we need to prepare today on both native and JVM side is to, in terms of runtime, in a few years, we are going to compete with WebAssembly, which is going to be used to run enterprise workloads with WASI and all the work that is done currently. And I think a lot of languages like Rust, like Go, are going to target WebAssembly as a kind of bytecode of their own, leverage an ecosystem of polyglot components, etc. And for sure, Java has maybe some stuff to do here, but I think that will be the biggest competitor for Java workloads. And so anything we can do to improve the developer experience, the runtime efficiency, and WebAssembly can basically start workloads with a teeny crazy latency. So I think all the work we are doing here with the runtime efficiency, small startup time, really matters because, yeah, this is going to be an interesting competition. I'm not sure how that will move forward, but yeah, competition with other language that will leverage WebAssembly as a vehicle to deploy workloads in a serverless way. I think this is a real upcoming competition.
Yeah, so I think you need to look at the motivation for adopting the new thing. Sometimes it's just developer enthusiasm, but other times there's like technical drivers of why somebody would want to go to Rust and Go. So if you look at Go, for example, I mean, I've played with Go, and like when you're actually writing Go, it feels like you're writing like Java 1 code because it's like the developer experience is outdated. It's very minimal, and it's by design. I guess by design. So for me, the only motivation that I think would want is because they wanted to make really efficient containerized microservices. Like if you look at Kubernetes, right? Kubernetes is written in Go, bunch of Go microservices, and you can run it on your laptop, and it's pretty efficient, right? When they first created Kubernetes, if they tried to do that in Java, and you run like 30 Java instances for each microservice to run Kubernetes on your laptop would have exploded, right? So I think there's a clear motivation there, and then GraalVM comes along, and it's like, hold on, we don't have to do this anymore, right? We don't have to do this anymore because it can be just as efficient in Rust and Go. And then the same thing with serverless, right? Before GraalVM came along, serverless Java just wasn't really a thing, because of, and now it's a viable opportunity, right? Or for example, deploying to like low memory footprint IoT devices. There's use cases that Native Image is enabling for Java workloads that just weren't viable before, and I think that's what's really exciting.
Very good. We're running out of time. We only have a couple of minutes left, so I guess I'll just I'll jump to the end here. So where do we go from here, right? So what's the future? I don't need the mic. What's next? Is Quarkus going to take over the world? Spring Boot's going to transform Micronaut? I mean, well, I guess Thomas is looking at me like I have something to say.
I feel we already covered that.
Well, I think what we haven't talked about is...
So the future is going to be looking like that you have an existing layered native image base, and within 1 second, your application is going to compile into a native image. And so the future is bright. I mean, the future is also going to be looking like we are trying to be covering more and more use cases that we see in the Java ecosystem to make it simpler and simpler to develop these native images. And we are thankful to a lot of library authors out there. We're only working together with framework authors, also library authors, like for example the authors of Netty, that are super helpful to work with to make sure that certain Java libraries are also supporting native image very well. And therefore I think over time I think it will be like even easier to build native images. And with the layered native images, you can then do that also at development time.
So in 1 year from now, we're going to have quite a different story.
And well, another part is also just that I hope, and cross fingers, that you'll see Helidon and other stuff pop up, and let's say the OpenADK will add these features like condensers and I forgot the constant static, whatever they call delayed instant. Having this notion of adding stuff to the language and to JVM that allows us to express the things that we are, for example, currently pushing in Micronaut and in Quarkus. And just, so for everyone who's here, like, you can get on the native image train today by using one of the frameworks. I have one preference, but that's it. But the good thing is it's here today, and we are, all of us, working with the OpenJDK team and with GraalVM to get to a better world together. But we have competition now, and that's a good thing. That's how we move forward. And Java is not dead.
Okay, we're out of time. So if you want to make a last statement, we can.
Yeah, no, convergence between the different behavior for runtime efficiency would be good. And also we need now to work on Kubernetes, reducing the latency introduced by Kubernetes, because native application, even with Spring Boot, start even too fast. And so it's the Kubernetes platform that is introducing most latency for scaling to 0. So now the work is on Kubernetes side.
Yeah, excited for the future. The layered images stuff is going to be a big deal, and just the continued evolution and the excitement that has been generated by this community to come bring new things to the Java platform as a whole.
Great,
super exciting.
Okay, we're out of time. Thank you very much, everyone, for coming, and thanks to the audience for attending this session. Thanks.